Welcome to Experiment 2. This is a digital brain for injection molding. 3 different partners participate in the experiment. Inymon, the end user, is an industrial company dedicated to plastic injection molding. MONTIMAGE, the ISB, is a software development company. ITAINNOVA, technical partner, and DIH is a technological center. Injection molding is a quite complex process, with many variables and complex dependencies. The objective was to create a digital twin as a tool or service for quick process setup and parameters optimization. The solution first requires a digital twin development process. This is done by executing a design of experiments of physically based simulations, such as the one we are seeing in the animation. Then the results are reduced and the digital twin is created. A graphical interface allows the user to operate the digital twin, to perform virtual trials and optimization, also to import data from the line for monitoring purposes and quality estimations. The solution has been deployed in the Digital Agora as 3 different applications. 2 of them support the digital twin development process. The other is the end-user interface. We are going to see a short demo of the last one. We are inside the platform. This is the ROM manager. Here we select the digital twin. There are 2 basic modes the user can interact with the digital twin. The first one is the tryout, which is used to perform virtual trials. In this table, we have the prediction of the digital twin for a particular combination of process parameters. We also have the alarms, in red when an output variable is out of the tolerances. On the graphical area, for any output variable, we can see the effect of all the process parameters. With the scrolls, we can change manually the values of the process conditions and perform a new instantaneous evaluation. We also have an optimization tool, which allows selecting a target, such as minimizing the cycle time, and the tool will provide the best combination of process conditions. The second mode is monitoring production and quality estimation. Here we import data readings from the line. We can directly plot the data for monitoring purposes. For example, we can see here the cooling temperature of the mold, but the most interesting capability is the quality estimation. For all the injection molding cycles, the digital twin performs an estimation of the output variables. The estimations are plotted, and it can be checked if any variable is out of the limits. For example, at this point, an incomplete filling of the cavity is produced. Finally, there is a capability that allows to incorporate real data from quality inspections in order to correct possible model deviations. Then the digital twin can be updated for future better estimations. These are briefly the main functionalities of the developed tool. The results of the experiment. From the end user point of view, we have a tool for the reduction of the time and cost required for the process setup. It's expected that this tool will allow reducing the number of real trials at less to 1/2. For already parts in production, the expectation is to achieve additional reductions of 10 to 15% in cycle time. For ITAINNOVA, the background solution CAELIATM Injection has been extended with extra functionalities and higher workflow automation. This will allow to shorten the digital twin development time around 20 to 40%. A much more attractive user interface has been developed by MONTIMAGE. The plans for the future are basically start replicating the solution in other injection manufacturing lines and continue improving tools. The digital twin development tools have been conceived in a general way and could be applied to other domains. ITAINNOVA will continue extending these software components inside the platform. That's all from Experiment 2. Thanks for your attention.